Now we're going to find limits numerically in the tables. This is a very straightforward method, but it's a little tedious. Suppose I start with the limit as x approaches 2 of x minus 2 divided by x squared minus x minus 2. The first thing you want to notice is, where is my limit going? It's going to 2. So I'm going to make a table of values. You want 2 rows, and you want, I don't know how many columns you want. In this case, I have 3 values approaching from the left and 3 values approaching from the right, where this would be my value 2. Now I'm doing this because this is the way the book did it. I prefer to actually have a column for the value itself, and you'll see that on the next problem. So you set up your table of values. Now, how do you pick what these numbers are? There are a couple ways you can do it. Okay, I'm approaching 2, and so that's going to be in the middle, but I want to back off of it. So I want to start closest to 2 at 1.999, and then 1.99, and then 1.9. To the right, I want to go to 2.001, 2.01, and 2.1. And generally, you want these two sides to be, if not necessarily equally spaced, but similar. So here, I'm going from 0.9 to 0.99 to 0.999. So I'm off by 0.1, 0.01, and then 0.1. So you just want to make them balanced. A lot of times you can do it like 1, 2, 3, 4, depending on the function. Now the bottom row is where you're going to put your functional values. Now you can see I've uploaded this from the textbook. It turns out this one is 0.3448. This one is 0.3344. This one is 0.3334. So it looks like, coming from the left, this is getting closer and closer to 1/3, or 0.333. Repeat. Now, is that the case? Well, let's see. Let me switch pen colors. Now I'm going to plug in the value 2.01. And I see that that gives me 0.3332, 0.3322, and 0.3226. So as I approach it from the right, the numbers seem to be approaching, once again, 0.3, repeating. Now, when you do this, you'll notice I didn't write down each and every step. I could have put 1.9 divided by 1.9 squared minus 1.9 minus 2 is equal to 0.3448. That is incredibly tedious. A lot of times you'll be doing this on your calculator, particularly when we're dealing with numbers, getting this small. So basically what you're going to want to do is to write out a sample problem. This is your sample. And then you can do the rest of them on your calculator. Now, if I wanted to solve this problem, which we did on a previous video, this is where I've got my 2 rows. And this right here is my limit point. The limit as x approaches 3. So, I mean, you can put 3 right there. I did put question marks. I don't know. It's just the way I do it. Now, my representative calculation. Hold on. Did I get this all set up? I have x in the top, f of x in the bottom. I started at 2.9, 2.99, 2.999, and then I am 0.001 to the right and to the left, 0.01, and then 0.1. So I have been balanced and fair, if you can put it that way. So you give me a representative problem. This is 1 over 2.9 plus 1 minus 1/4 divided by 2.9 minus 3. Did I do that correctly? And that's minus 0.0641. After that, you can go ahead and do these iterations on your calculator. Now it goes from 0.0641, 0.0626, 0.06251. What does this appear to be approaching? As we come from the left, it appears to be approaching 0.0625. We'll see. Let me take it from the left. If I look at the numbers from the left, it starts at minus 0.069, 0.0609, excuse me, 0.0623, 0.06248. See, this is, again, appears to be approaching 0.0625. If I want it to be even more sure, then I would, of course, do another iteration at 2.999 or 3.0001. I do want to point out that these do not have the same values. A lot of times when we do our problems, there will be symmetry, but in this case there's not.